I'm going to use the desktop process to illustrate the difference between positive and negative feedback. Normal automatic mode is characterized by negative feedback, which means any change seen in the process variable, such as from a load, is going to be reacted to in opposite direction. For example, when this controller is running, I'll start it up in manual mode here, get the motor running. When the motor is running at a certain speed, and I throw this into automatic mode, whenever it sees a change in the motor speed, such as when I touch my finger to the shaft of the motor to reduce speed, as speed goes down, it raises the output to try to correct for that change. As the speed goes down, the controller puts more electric power to the motor to offset or to counteract that load. That's called negative feedback. One easy way to think of this is when the process zigs, the controller zags. When the process goes one way, the controller tries to drive it the other direction. That is an inverting or negative feedback system. And that's exactly what we want out of any control system. Well, I'm going to throw a wrinkle into this whole loop here by changing the response of my variable speed circuit. Right now, the variable speed drive takes a 420 milliamp signal from the controller, uses that to throttle the electric power to the motor, and currently it's set up for direct action. That means a greater milliamp signal puts more power to the motor, which means, of course, in that mode, as the bar graph on the controller goes up and drives towards 100%, it's going to drive more power to the motor. That makes intuitive sense, but it doesn't have to be that way. I can, for example, go to the variable speed drive. I can pull out the load jumper right here to shut off power to the motor. I can move another jumper from direct action to reverse. Right there, that's the direct reverse jumper. So now when I apply power back to the motor, the variable speed motor drive will act backwards. Now a higher milliamp signal will cause the motor to go slower. Watch what happens. Now here we go. And at this point, I'm going to throw it in manual mode. With 100% output, 103.3, the motor's fully at a standstill. As I reduce the output, though, watch what happens. The motor now begins to spin. You can hear it. You can also see it on the process variable bar graph. As I reduce the output even more, the motor spins faster. That's because I've made the variable speed motor drive now a reverse acting unit. Less current signal to that variable speed motor drive makes more power go to the motor, makes it spin faster. So basically I've made my variable speed motor drive act backwards. This has profound effects when it comes to controlling automatically in automatic mode. So let's see if I can adjust this and get my motor speed somewhere around 50%. Let's check my display here. 48.8, that's pretty close. So my motor's spinning at approximately 50% speed. At this point, I'm going to throw it into automatic mode. Now remember what the controller tries to do. In automatic mode, if the controller sees a decreased motor speed, it tries to send more power to the motor to counteract that. But in this case, greater signal to the motor drive will actually cause the motor to slow down even more. Conversely, in automatic mode, if the controller sees a higher motor speed, its natural reaction is to cut power to the motor, to reduce power. But since we've now reversed the action of our variable speed drive, reducing that signal is actually going to cause the motor to go faster. So what we're going to see is a runaway condition. Either this is going to run full speed or go all the way to zero when we put it into automatic mode. It may take a little while to do that because when I first make the switch from manual to auto, I will begin with zero error. It's going to be happy right there. It won't change a thing. But if anything at all happens to slightly change that motor speed, it will go either all the way saturate full speed or all the way saturate to nothing. Let's watch. I'll switch to automatic mode. Let's give it some time and just see what happens. It's only a matter of time before something takes place. There we go. Something slowed the motor down. In response, the controller sent a higher output signal, which in this case, unfortunately, drives the motor even slower, and so on until the motor's at a full standstill. I can go back to manual mode, decrease my output signal to make the motor spin again. Remember, with the backwards motor speed drive is kind of confusing. Okay, I'm going to throw this back into automatic mode again. We'll see what happens. I'll try that one more time. It may do the same thing as last time. It may even go faster. It depends what sort of error takes place. Whoop, looks like the motor's going to go to a full standstill once again. Something made it go slow. That caused the controller to respond in an inappropriate direction, causing the motor to go even slower. That's an example of positive feedback. It completely saturates in one direction. If I try this enough times, eventually I'll run into a circumstance where the motor runs away full speed. Let's see if we can get that to happen. I'm going to go back to automatic mode. Let's just watch and see. Nope, it's going to slow down again. Let's try this. I'll catch it before it stops entirely. Try back in automatic mode. Let's see if we can get lucky and have the motor run away full speed. There we go. Something made the motor go a little bit faster. Now the controller once again is taking inappropriate action. It's driving the output signal down, which in this case, because we've reversed the variable speed motor drive action, makes more power go to the motor, makes the motor spin faster. Once again, an example of positive feedback that results in complete instability. Let's switch back to manual mode. I'll basically drive the motor off. Negative feedback, the hallmark of it is self-correction. The hallmark of positive feedback is that it tends to fall completely one way or the other. It's almost like balancing a pendulum on end. It's a naturally unstable system. It can remain perfectly balanced at one location and one location only, but if it begins to tip in one direction, there's really nothing to stop it. It falls completely over, either completely, in this case, off, or in this case, full speed. And we've seen both examples happen here with positive feedback. All we need to do, however, is go over here and reverse the action of our variable speed motor drive once again, so it is now direct acting. And when we do this, I'll decrease my output so we're not surprised by a runaway motor. Plug in our load jumper, and now we should have a properly controlling system. Negative feedback. I'll throw it into automatic mode, and here we go. I can slow down the motor, and it corrects and stabilizes. It does not run away like it did before and either go all the way off or all the way on. This, once again, is negative feedback, the way it should be for a stable loop.